Hey guys, today we're looking at STK, System Toolkit by ANSYS for beginners. This is a very bare bones initial introduction to System Toolkit. We'll really cover only the basics. STK is predominantly used in orbital dynamics. This tool, in addition to modeling position, also models time. So it tells you where a satellite or an object is in space and time. If you add in the time component, you can know where the object is in time, where it was, and where it's going. We don't really care what this object is. It could be a star, it could be a satellite, it could be a submarine, it could be a planet. It could be an airplane, it could be a ship. So many different industries use this system toolkit, and it was previously known as satellite toolkit, but due to the variety of applications, ANSYS now changed it to system toolkit. The name is now systems toolkit, but the genesis is satellite toolkit. So STK does a variety of things. First, it tells you where an object is, where it was, and where it's going. The next thing it does, it tells us what an object can see. So when you send a satellite up to space, we want to know, what can the satellite see? How can I complete my mission? And finally, STK also is useful for knowing who can see me, who can see this object. First thing, start STK, and then you see the licensing. For now, we're going to use the STK Enterprise option. If that's not available, use the STK Premium Space. There really shouldn't be a big difference between them for what we're doing right now for these capabilities, so it doesn't really matter too much. It takes a few seconds here for STK to start up, so just give it a little bit of time. So the first thing you're going to see is scenario, create a scenario or open a scenario, and scenario is widely used in STK. So we want to think of scenario as a basket or a folder of objects for which you want to do analysis in or with. We're going to load those or pick those into my scenario. So the scenario we're looking at today is, tell me from Blacksburg, Virginia, where I can see the ISS from Blacksburg, Virginia for the next 7 days. So we want to know when from Blacksburg we can see the ISS. Go ahead and click the Create Scenario button. This next pop-up allows you to describe the scenario. Top and the name, you can name it whatever you want. For now, I just ignored it, and I want to look at the start and the stop towards the bottom. As mentioned, we want to model space and time. Here, we're going to specify the time. This is essentially the timeline. You want to think of it as a timeline. So we mentioned that we want to look at the next 7 days. So the constraint is from today to the next 7 days. In the start time, here is a little shortcut. You can just type in the word today. Next, I want you to highlight the stop time and type in +7 space days, and then hit OK or enter. It takes a little bit of time, but once it loads, you will see this graphics window and an initial window that says Insert STK Objects. For now, we want to close this, but we will come back to it later. Next, if we see the far sort of left side white column, the blank column, that is our object browser. In here, we're going to add and see all of our objects. Next thing we're going to look at on the bottom here, that blue bar, that's actually our timeline. That represents our 7 days. If you have different objects at different times, it's great to have a timeline to keep track of all of them. In this video, we won't be using it, so for now we want to close this timeline. This just gives us more of that screen real estate. Next, we're going to go up to Window on the top left, and then select Tile vertically. And this just increases the size of those two windows, the 3D and the 2D view. So the 2D map and the 3D map, it doesn't matter what side they're on. But first we're going to start with the 2D map. Mine is on the right side. You can use your left side mouse button to sort of zoom in and out. The maps are interchangeable with data, and it just shows you the two views. The view on the left side is your 3D view, and you can use your mouse to move around that globe. In the 3D view, we can see that the globe is clearly it's shadowy. This means that night is turned on, so you can see nighttime and daytime according to the sun. If you look on the 3D window, on the top toolbar, you see a rocket with yellow coming out of it. That's actually a flashlight. So we're going to click on that, and that's going to make your dark site a little brighter so you can see better. And this is just a visual thing, so it makes the objects easier to see and easier to work with. Essentially, we're going to not only look at the satellite's position, but we're also going to look at the attitude. For an aircraft person, that's basically the same as yaw pitch roll. How is the satellite oriented at that point in time? On Earth, we essentially just use gravity to determine those parameters, but when you're in space, it's a little bit different. So we want to know how the satellite is oriented. One of the things a lot of satellites do is they use stars, star tracking. So they see a known star and use that information to determine a attitude. It's pretty cool that they have a sort of star map. You'll notice that two of the objects you'll see, the sun and the moon. So another cool feature is that if you're ever in the 3D window and you're poorly oriented or you're zoomed in too much or zoomed out too much, a cool feature that I like is the icon on the toolbar. It's that eye with the house on it. If you click on it, it'll take you directly back to where your object is, and it'll give you that home orientation. Keep in mind that STK has a lot of capability. Right now, we're just showing the bare bones in the intro, but if you dig around on the internet or if you just play around with this software, you will notice that there's a lot of capability. It's pretty neat. It's pretty cool. Now that we have essentially the basics down, we want to continue with setting up our scenario. Our scenario again is tell me when I can see the ISS from Blacksburg within the next 7 days from today. To do this analysis, we have to add in objects. Go to the toolbar up on the top left and select Insert. And click on the first one down from the top, called New. Here we'll see another pop-up window called Insert STK Objects. We don't want to select anything yet. First, go to Edit Preferences, and one of the objects that you want to select from the pop-up window is Planet. That by default is off or it's unchecked. We don't really need it tonight, but it is nice to have for future projects, especially if you're doing an out-of-orbit mission. Like for example, you think, hey, I want to add a Mars in. Where is it? And so you just check that and it'll show you. We won't need it right now, but that's where it's at. So all these things on the left side of the window, these are essentially just things that we bring into STK during our analysis. The bar on the right side is essentially telling us anytime you add an object in, how do you want to define that? So it's the method or reason. We already have the 7 days in scenario, so now we want to move on to the next thing. Let's start bringing these objects into STK. So we're going to enter this as a city or place. So that's the icon on the left side, sort of towards the middle, called place. So if we look to the right of that, it's going to ask us, how do we want to define that? The one we're going to select is the second one from the top, called From City Database. Select a place from city database, and then on the bottom, select Insert. Here in this pop-up, up where it says name, we want to put in Blacksburg. And then click the search at the very bottom. Here we see Blacksburg, Virginia, not South Carolina. Make sure you select the correct one. And then one feature I want to highlight is here at the very bottom, you have the color. So that's how it's going to be represented with that color. The color is important because STK is great for visualizing those satellite missions. You want to pick something that stands out, that is unique from the other objects, and that will give you clarity in how your mission is progressing or how it progressed or where it currently stands. Make sure that objects don't blend in with each other, that they stand out from each other. So when you're showing what you've done and you put a lot of effort into it, you want to make sure that additionally it's very clear. If you have Blacksburg selected, go ahead and click Insert. And if you close this window, we will see that Blacksburg is now clearly defined on both maps, the 2D and 3D. In my case, I accidentally selected Insert twice, so it located Blacksburg twice. If this happens, it's very simple. Just right-click the one that you want to delete and delete it. Next, right-click on Blacksburg and select the second one down, Zoom to. This is just going to zoom us into wherever it believes Blacksburg is. We'll see like a Google Maps imagery. Mine is pretty pixelated. It does have capabilities for it to be higher quality, but mine was not very refined, as my network was pretty slow. You essentially have imagery there to kind of determine, is this the right place? Using the right mouse button, you can zoom in and out, and then using the left mouse button, you can rotate. Next, we're going to insert our satellite. We want to follow similar steps to what we did for the place. You go to Insert, New, select Satellite from the Select an Object to Be. To select a method, select the first option from the top from Standard Object Database. Select Insert. Next, where it says Name or ID, type in ISS. Here we see 183 results came up. This is obviously crazy and is going to be more difficult and less efficient for you to find the ISS. Go back to that name or ID, and instead of typing in ISS, type in Zarya, Z-A-R-Y-A. This is essentially the module of the ISS that is referred to as Zarya. This means sunrise in Russian, and the name symbolizes the beginning of a new era of the ISS cooperation, since Zarya was the first component launched for the ISS, marking the start of its assembly and operation. So historical context is pretty cool. So if we type in Zarya and then hit search, we'll notice that the search quickly comes down to only 2 results. Click on the ISS Zarya, that first one that comes up, since it's the actual database that it's pulling from. And then make sure the color is distinct from the previous cyan color we used for Blacksburg, just to clarify and make sure that's distinct from each other. Here I'm simply keeping it as green. Ideally, you probably want to change it to something like red, so it's very, very clear that it's opposite from Blacksburg and that you can just see it more clearly, but green works as well. And next, select Insert. And if we close this window, we will see that Zarya ISS is clearly orbiting the Earth. Now on the 2D view, we can see the clear trajectory that the ISS is following on a more flat plane. So we can see that sort of sinusoidal wave going up and down. And then on the left side, we can see that 3D view, that simple orbit that it takes. Another cool feature is that if you right-click the ISS on the object browser and you select zoom to, you can very clearly see the ISS and rotate it and see some very fine, very cool details on it, such as the ESA logo. And you can clearly pan all around to just check out the cool details of your object. A little bit above, we have this ribbon of toolbox that will allow us to see the movement of the object trajectory. If we click on that start button, we can clearly see the object moving, and we can orient and pan all around to see trajectory. One of the buttons is increase time step and decrease time step. So this will increase how fast or how slow your object is moving or advancing. This is all in respect to the time frame that you gave it. So for us, it was that time frame of 7 days, starting from today, which is February 5th, to those 7 days. So here we can increase that time step to make it go faster and just give us our final results, or slow it down if we need to meticulously check that trajectory. You also have the option to move forward and move backward by 1 step. So 1 step forward or 1 step backward. So you have the option to start, stop, and say, for example, you increase the time step a lot and you accidentally went all the way past your time of 7 days. This is something common that happens. You go past your time frame that you allotted for your scenario and you no longer see your object. And people often go, oh, hey, I lost my object. I don't know where it is. How do I get it back? This is because in this scenario, we specified the 7 days from February 5th to the 7 days plus. So if you go to, for example, February 18th, that object will not be there anymore because it's past those 7 days that you specified. So a quick way to sort of get back to your original point is to simply select that red icon, that reset button, and it will take you back to the very start of your trajectory or your 7 days. Next, we're going to right click on Blacksburg, then Access, then ISS. So here we're going to see the start and the stop times we specified, and you want to select that Access button under Reports. And on the right side, you're going to see that sort of waffle fry shape pop up over Blacksburg. So when you click on this report, STK essentially calculates the line of sight geometry between your place object and your target object. This report is going to pop up, and we're going to expand this so we can better see our data, and we can see clearly here the start and the stop times. So on the very left side, you see the numbers in chronological order. These are the axis number. This is a chronological count of each time the window of visibility opens. So the start time is the exact moment the target enters the place's field of view, and the stop time is the moment the line of sight is broken. And then on the very right, we see the duration, which is the total elapsed time for that specific pass. And finally, at the very bottom, we can see the total duration, the total elapsed time for the passes. So if we look at that 2D map, we essentially see that waffle fry that we saw before, and it's full of streaks, and each line is the path the satellite takes as it orbits the Earth. Because the Earth is rotating underneath the satellite, each successive orbit shifts slightly to the west, which creates a sort of crisscross pattern that we see in this 2D map. Again, the report on the left is a list of every time the ISS passes directly over or within view of Blacksburg. And the grid shows everywhere the satellite goes during the analysis period from February 5th to February 12th. Every time one of these teal lines passes close enough to the green dot labeled Blacksburg, STK marks it as an access and opportunity for contact. Another cool feature is if you highlight, for example, a start time. For now, I'm selecting an arbitrary start time and then select set animation time. The maps will clearly show us that exact time on the map. Now, if we look at our 3D map, we can orient the ISS so that we can see exactly where the ISS is looking at Blacksburg from. On the 3D map and also the 2D map, but you can see it better on the 3D map, you can clearly see the access line that connects the ISS to Blacksburg. And this is essentially a dynamic visual indicator that signifies a valid line of sight that exists between two objects based on the current animation time. You can also change the line properties, but for now we're just going to keep it as is. Next, we're going to select that Access tab again. Here I have it at the very bottom, so I can very easily just click on it and access it. Another way to access it as well, as I'm showing, is right-clicking Blacksburg and then select Access. Now this time, instead of selecting Access like we did last time under Reports, we want to select AER. This stands for Azimuth, Elevation, and Range. So again, this is similar to yaw pitch roll. So azimuth is where to turn, elevation is how high to look, and range is how far away. So while the standard axis reports tells you when the pass happens, the AER report tells you where to point. So again, azimuth is that horizontal compass direction, elevation is the vertical angle of the satellite above the horizon, and range is the straight line distance between two objects, whether that's in kilometers, nautical miles, or some other unit. So if we scroll, we can see all of the different times where this is represented. Here I picked an arbitrary one so that we can clearly see this. If you highlight the time and you right click it, the menu pops up and you select time and then animation time, set animation time. And this will give you the setup that we had last time. We go on this 3D window and we rotate and pin around, we can see the ISS is essentially directly above Blacksburg. So if you have an AER report or graph open, the time cursor, the red line, will move to that point, showing you exactly what the azimuth and elevation were at that moment. Next, we want to click on the Blacksburg within the object browser, and this basic position screen will come up. So these changes are going to be pertaining to mainly visuals. So on that left tab, you want to go under Constraints and then select Sun. Here on the right side, check the lighting box, and instead of direct sun, change it to umbra from the dropdown. So here what we're doing is that by checking lighting constraint and then selecting umbra, you're telling STK to only consider an axis valid if Blacksburg is in total darkness, so the Earth's shadow. This essentially filters for nighttime and effectively filters your axis report to only show passes that occur at night. If you want to physically walk outside in Blacksburg and see the ISS with your own eyes, you need it to be dark at your location, so umbra, while the satellite itself is in the sun to reflect the light. So this will have to be bright. So select OK. And if we open that 2D map again, we see that instead of having those waffle fries, we now have the French fries. So since we now have more filters, we will have less passes for our specific scenario as we specify it more and more to only be during the nighttime at Blacksburg. We want to see the direct numerical impact of this change. So go to the reports tab at the bottom. Your report again will open up, and so you want to hit that icon that has the 2 arrows, essentially like a recycle bin. This is the button to refresh this report since we have applied new filters to our scenario. So hit this icon. It's going to take a little bit, but after a little while, it should give you the reports of the total passes for your new scenario. So you can see at the very bottom that that number went from about 1900 to now 1700. Now we want to do something similar for the ISS. On your object browser, instead of clicking Blacksburg, you want to select ISS. Go to its properties like we did before for Blacksburg. Go to the constraints, go to sun, check that lighting box, and then for the dropdown, instead of selecting umbra, we want to select direct sun so that we're able to clearly see the ISS during the nighttime, and then select OK. Go to the report and then hit that refresh button again. So these new filters are reflected within the report, and we can see that the number of passes for the specific scenario drop down a little bit lower. Finally, we want to close out of all of these reports and see where the ISS is exactly in relation to Blacksburg. Again, we can pan, zoom, rotate to look at the different angles of the ISS. And you can hit the icon with the eyeball in the house to go back to that home view. And that's going to be all for this video, guys. In just a few minutes, we've gone from a blank scenario to generating a full 7-day axis report for Blacksburg, Virginia. Let's go over a little bit of what we did. We visualized the ISS ground tracks, checked our lighting constraint for those nighttime view opportunities, and decoded the AER reports so you know exactly where to point your eyes or your sensors in the sky. STK is an incredibly powerful tool, and what we did today is just the tip of the iceberg. So whether you're planning a satellite mission or just trying to spot the ISS from your backyard, the data is now very clearly at your fingertips. So if you found this helpful, hit the like button and subscribe for similar content. If you ran into any issues with your constraints or your axis lines aren't showing up, drop a comment down below and I'll do my best to help you troubleshoot. Thanks for watching and happy orbit hopping.